Okay, we all see it still? All good?
Yeah.
I mean, a simple trick to remember, I usually say this to everybody, everything is going to be 1,000 for you. So if you want to ever remember how many grams in a kilogram, it's 1,000. How many kilograms in a ton, it's 1,000. How many milligrams in a gram, it's 1,000. How many milliliters in a liter, it's 1,000. Liters in a kiloliter, it's 1,000, and so on, right? The only, like how many megaliters, how many liters in a megaliter? Well, a liter goes first from liter to a kiloliter, then a liter goes to a megaliter. So 1,000, and then again 1,000. So the idea is always 1,000, right? Unless you're skipping, like in this case, you're going from centimeters to kilometers. The only one that's it's not 1,000 is obviously distance, and I think most of you guys, I think I know this already, but this just goes 10, you add an extra 0 becomes 100, add an extra 0 becomes 1,000. But otherwise, everything else is always going to be 1,000 for you. That's all good.
Yeah.
And then again, if we're going from big to small this time, big unit to small unit, you got to multiply. Again, small to big, you got to divide. So this case, you're going from small to big, you're going to divide by 1,000. Here you're going from big unit to small unit, you times by 1,000. Does anybody want me to explain that further, or are we okay to move on?
Very good.
No, we're good.
Just be careful if you are, like I said, you're skipping, like liters to megaliters, you're skipping a bit. So it's 1,000 and another 1,000, which means it's a million. A good point, actually, now that we're here, with meters squared and centimeters squared, it is not 100.
It's 100 squared.
It's 100 squared. Good job. Now, if you're doing 1 meter cubed to centimeters cubed, again, it's the same thing. It's not 100, even though there's 100 centimeters in a meter. It's 100 cubed. If I ask you to go from 1 centimeter squared to 1 kilometer squared, again, you go 1 centimeter squared to a meter squared, then to a kilometer squared. How small to big? You're going to divide by 100 squared, and then again, small to big, 1,000 squared. All good?
Yeah.
So if it's area, it's squared. If it's volume, it's cubed. If it's normal distances that you've been doing here, then it's just, 10, 100,000, whatever. Cool. Yeah, let's do this. Christian and Bianca, I'm guessing you haven't done error.
For the lower limits.
Yeah, lower limits, upper limits. Okay, so you've done that. Bianca, what about you? Have you done that as well?
Yeah.
Okay. Girls, do you girls still remember everything as well from error?
Yeah, we're doing that now.
Yeah, mostly.
Yeah, nice. So, what was the magic number for errors?
The absolute error.
No, what's the magic number?
One.
Half. Alyssa, can you talk again?
Yeah.
You're too far away from the mic. I can just barely hear you.
Sorry.
Yeah, well, that's better. Say it again.
Half.
Yeah, that's much better. Now I can hear you. All right. I don't know. Maybe you've been talking before and I couldn't hear you. Sorry. Half. Yeah. So the magic number is half of my unit that I'm measuring in. Just keep that in mind, okay? So that's my actual error. So the error I'm trying to look for is half of my smallest unit of measurement. Or I just call it half of my unit. So you guys got to remember half. This is a nice, easy one to start with. I like it. It's a speedometer, obviously. It's going up by what?
20.
20. So if I was to ever measure this, I can only measure it in increments of 20 kilometers per hour. Okay? So my error would be half of 20, which is 10 kilometers per hour. but I want to make something clear because we spoke about this in my class. If I did this all of a sudden, which is the way it looks usually in cars, right?
5,
Yeah.
What's it actually going up by now?
10.
10.
So therefore, my error in this red, is half of 10, which is 5. So you've just got to remember that. The idea of the unit is how am I measuring this particular situation? Like if you're driving, you're measuring it in either increments of 10s or 20s. If it's a ruler, are you measuring it up to the nearest millimeter, or are you just interested in centimeters? Or if you're building a house, are you just measuring in terms of meters? It just depends. Okay.
Mm-hmm.
Usually it's millimeters for a house anyway, just to make it clear. But whatever. All right. So this guy, half of what? What's it going up by?
0.5.
0.5. Does anybody not agree with that? Okay. The answer to this becomes 0.25. So obviously it says find the limit of reading. The limit of reading is just half. I'm not interested in just the half. I'm trying to answer the error bit as well. We're answering error. All right, this one, it's going up by 1 mil. So 0.25 centimeters. This one's going up by 1 mil. So the answer would be half of 1 mil, which is 0.05 of a millimeter. Ugh. Okay, any questions there?
No.
No, when we're talking about error, we can obviously overestimate and underestimate error, right? You could, like if you were saying, hey, I was traveling 80 kilometers per hour, that means you could have traveled 90 kilometers or 70 kilometers. So you had a boundary between 70 to 90. Yes?
Yeah.
So we've got a question here. It says the length of a piece of cardboard is measured to be 62 centimeters. If I'm saying it's 62 centimeters, that means I'm technically going up by
1 centimeter.
1 centimeter. So it's half of 1 centimeter, which becomes 0.5 of a centimeter. That's my error. Between what two values does the true length lie? Therefore, it can be between 61.5
And then 62.5.
and 62.5. Gills, Cara, everybody still remember all this, right?
Yeah.
Yeah.
Yeah, nice. Christian, makes sense to you. It looks like you get it pretty well as well. This one, Abby's father measured her height. It's 130 centimeters. However, they were measuring it to the nearest 10 centimeters. So it's not going up by 1 centimeter. It's going up by 10. So my error equals half of 10 equals 5. So therefore, my lower bounds and upper bounds, I like to draw them like this. I like to use square brackets and just go 130 take away 5 is 125, comma 130 plus 5. In math, if we ever use square brackets, it means everything from 125 all the way to 135. So all the numbers from 125 to 135. Your teachers will be very impressed to see your square brackets if you want to do that. All right, I'm just going to move on. Like I said, you guys can do this for homework. I know that. Absolute error is error. Okay, just so you know, the absolute error is error. Percentage error is your error over
Percentage error.
times 100. So error over your original number times by 100 to get into a percentage.
Yeah.
I'm going to do. We're going to do. Yeah, question 7, question 8, and we'll do question 9. Okay, question 7. A commentator at a soccer match estimated the crowd at 2,400 to the nearest 100 spectators. Find the percentage error. Well, error equals
50.
times 100 equals 50. So therefore, percentage error equals 50 on 2,400 times 2.1.
Yeah,
One?
2.08.
No, yes, it says 2 decimal places, 0.8%. All right. The measurements of a rectangular plug are 36 by 28, the nearest centimeter. Between what lower and upper limits does the actual area lie? Okay. Again, girls, we've done this. Do you want to remind us what we're meant to be doing? Do we first, my question is this, do we first find the area and then do the upper and lower bounds? Or do I find my upper and lower bounds of each length and then find my area? Farah, do you remember?
Do we find the upper and lower bounds first?
I think so, yeah, you're right. So we first, look, the problem is this, if you're going to ever, I mean, because you're estimating, right? I mean, there's room for error. Now, the error wouldn't have occurred from your area. Area is basic. You're just multiplying your two lengths that you have. So the error wouldn't have occurred from the area. The error would have occurred from your lengths. So maybe your lengths weren't exactly accurate because of, I don't know, let's say because of the machine's a bit faulty, it wasn't exact. So and that's the way we're going to tackle this. So the area works like this. And Christian and Bianca, that makes sense?
Yeah.
So what we're going to do is first find my error. Error equals half of 1, which is 0.5 centimeters. So that means the lowest this could have become is 35.5 to 36.5. And then same thing with the other one. It's going to be 27.5 to 28.5. Which means my area is going to be between 35.5 times 27.5, which is 976.25, and 36.5 times 28.5. That one is the one that's usually asked in an exam. Again, I think you know why it's asked is because it just tests the idea of area, which most students go and find the area first and then do the error. And that doesn't work out. Okay, that makes sense?
Yeah.
Any questions for that? Question 8?
No.
Okay, question 9. Lucas measured the length of one side of a cube as 15 centimeters. See, he's measuring it, so he's the one that could have done it wrong. It is a cube. Between what lower and upper limits does the actual volume of the cube lie? Well, the area being 0.5 of a centimeter, so that means the length could have been 14.5 to 15.5 centimeters. Now to find the volume of a cube, you're just going to cube these, right? Volume of a cube is 14.5 times 14.5 times 14.5. So it could have been from there all the way to 15.5 cube. There's no need to put that in. You can just leave it like that. Between what lower and upper limits does the actual surface area of the cube lie? If you remember, surface area of a cube is x times x,
Yeah.
and then times it by 6.
Times 6 is, yeah.
Yeah, nice. So technically, your length is 14.5, so it could have become 6 times 14.5 squared, all the way to 6 times 15.5 squared. Let me know if you've got any questions there. Copy that down. All right, we're okay to move on.
Yep.
Yeah.
Yep.
Let's do it. Scientific notation. Do I need to go through this?
No, I'm good with it.
Anybody else that can see my answer and go, I don't know what you've done?
No, I don't.
Okay, all good. So start
Yeah.
from 0. They're all negatives. These ones. The number you begin with must be bigger than 1, but smaller than 10. So like here, I didn't choose 53. It's 5.3, and then 1, 2, 3, 4. Here, it's not 6,532. It's 6.532 times 10 to the power of. Go back 1, go back twice. Okay. Express as
Yeah.
ordinary numbers. You just plug it into your calculator. Standard form. 3 significant figures. We'll just need figures. I think together is probably better than just doing it in there. So I'll come back to sig figs. That's nothing. Using the conversion. All right, let's do this. Food and nutrition. Did you do food and nutrition last week with Dan, or you didn't get time to do that?
No, we did.
No. All right. Use the conversion. Sorry. 1 calorie equals 4.1868 kilojoules. This will be again given to you in your formula sheet. So complete to 1 decimal place. If you've got 320 of this, you'll just do if you've got 3,400 kilojoules, you want it into calories, well, that'll just be 3,400 divided by 4.18. Do we all agree with that?
Yeah.
Yep.
Okay. This one seems easy again, per 100 grams. Question 3, find the value. I think we'll do question 3. Yeah, we'll do question 3 and I'll leave question 4 for, let's try to read this. The table shows the nutritional information on a box of muesli. Let's first read the box and understand this. We've all seen this before, but let's just make sure. Nutritional information, servings per pack. There's 11 servings per pack. Serving size, each one is 45. So that means in total, the whole packet that you're buying is 45 times 11 in size, which would be what, 495 grams, right? Energy, average quantity per serving is missing at the moment, and then it's 196 calories. But I was given the average quantity per 100 gram, so I can convert that to per serving if I needed to by just working out how many times 45 goes into 100 and then dividing it accordingly, which I'll do with you. Protein, there it is, fat and carbs, fiber and sodium. All right. What is the total mass of muesli? Look at that. Without even reading the question, we've already answered it. What is the total mass of the whole box to the nearest 100 grams? What's the answer?
500 grams.
500 grams. That's 495. You've got to round up to the nearest 100, which is 500 grams. Everybody understand how I did that 45 times 11 bit as well? 45
Yeah.
grams. Yeah, and there's 11 servings. All right, to the nearest whole number, find the value of A. Okay, now you know 100 grams, it's 1826. But per serving, and each serving is 45 grams. So I've got to work out how many, I guess, yeah, how many times 45 goes into 100. So the best way to do that is just do 100 divided by 45.
Yeah, 2.22.
2.22 repeater. Good job. And then all you're going to do is just do 1826 divided by that answer. and it says to the nearest whole number, that should become 822.
Yep.
Now the number I'm using, you guys, just in case some of you might use 2.2 or 2.22, I'm using the whole answer. So I'm actually using 2.2222 repeater. What I'm using in my calculator is 20 over 9. So I use the fraction instead of the decimal. All right, that makes sense?
Yeah.
B, now I'm going to multiply it by 2.22, or in this case, I'm going to multiply it by 20 over 9. So 196 times 20 over 9. I get 436. Let's just see. If you had chosen 2.2, I just want to see. Yeah, see, if you chosen 2.2 only, you would have been very far off. You would have got 431. If you chosen 2.22, you would have got 435, which is still wrong. So check that out. If you had done 2.22, you would have got 435, which would not have worked. So please, you guys, you can never use a rounded answer. I like to use fractions for that in that case. So yeah, don't use a rounded answer. You can write it, don't use it. Okay. If 15% of the total fat was saturated, find the value of C. Well, that's very easy. 7.8 times 15%.
1.17.
Grams, yep. And then what percentage of the carbs were sugars? Well, again, that's easy. Sugar over carbs. To the nearest whole percent. So to the nearest whole percent, anyone can tell me the answer to this?
It'll be 30% if you round it up.
Correct. And last one. Each morning, Eric pours 250 mils of low-fat milk into a bowl containing 60 grams of muesli. 250 mils into 60 grams. Okay. He knows that 100 mils of the low-fat milk contains 180 kilojoules. What is the total amount of kilojoules consumed to the nearest kg? Okay, well, first thing, let's do milk, since we're breaking this up. So milk plus milk. He knows that 100 is 180. Obviously, he has 250 of them, so that would be 2.5, right? 2.5 times, or 250 over 100, however you're looking at that. So 180 times 2.5 is 450 kilojoules for milk, plus 60 grams of muesli. Where are we? Okay, so we want 60 grams, but we only have it for 45 and 100. What I would do is I would probably go and convert again, like we did with 45 grams. So I would do 100 divided by 60 to work out how many times that goes in. So 100 divided by 60 simplified becomes 5 over 3. And then I would do 1826 divided by 5 over 3. And that should tell me exactly how many kilojoules of muesli I'm having. In total, the nearest kilojoules is
146.
Yep. Christian, that makes sense?
Yep.
Yep. All right. Double A. What percentage of the recommended daily intake has Eric consumed already at breakfast? Well, 1546 over 8,700, and then again times by 100.
So 18%.
It does say to the nearest
Yeah.
One decimal point.
17.8.
17.8%. Any questions there?
No.
No? Everybody's good with that? Okay. Electricity time. And last one. What's the time anyways? Oh, we're doing well. How good's that? We finished the whole topic. Good. Let's have a look at this. Measurement 1, energy consumption. Yeah, maybe we'll start off with the basic one first to understand this. Okay. So let's learn how this is a little bit different to the normal ones that we usually deal with. Normal rates are milligrams per milliliters, like we saw that in medicine, or kilometers per hour. We saw that with braking distance. I don't know. Yeah, we just did kilojoules and calories and stuff. Per average quantity per gram, so converting milligrams into grams and whatnot. Okay. This energy works a little bit different because it says kWh. So it's not over H, it's actually kWh, which means kilowatt hours. Because there's no, division sign or your fraction sign or your slash sign here, or forward slash, whatever you want to call it, kilowatt hours, that means that's actually multiplied. So this one is kilowatt times hours is kilowatt hours. Okay? Is that clear to everybody? Firstly?
Yeah.
So if I told you the washing machine was on, has an energy rating of 30 watts, and you were running for 2 hours every day for 365 days, the way it works is 30 watts times 2 hours times 365. 30 watts times 2 hours times 365. So I get 21,900 watt hours, because that's W times H. But I want a kilowatt hours, which means I'll divide that by 1,000. Are we all clear?
Yeah.
I got a kilowatt hours. But to get WH, you had to multiply watts with hours. It's very important because everything you've learned up to today, every rate we've ever done has usually been like something over something else. Especially if it was like kilos, so kilometers, kilograms per hour or whatever. It's never been times hour. In this case, it's going to be times because it's the amount of output it has, the amount it's actually using. So it's using 30 watts every hour for 2 hours for 365 days a year. And that would be the amount of energy it uses per year. And then of course, if you have to do price, that's very easy. You just times it by 53.91, whatever. That bit's easy. It's just this bit here, kilowatt times hours, really gets everybody. So you got to remember it's always multiplied for energy. All right, let's have a look at how this works. I would recommend, honestly, just to get one of your parents' bills and actually read the whole bill, because now with exams they are providing the full bill, and you've got to learn where everything is and how it looks, the words that they use and everything, right? Because you get charged for what we say is usage compared to supply. So you got to learn to read these words and understand how this actually works. Usage is obviously what you use. Supply is the fact that they have to even supply you with like gas or electricity or water in the first place, let alone if you've got to use it. So please, tomorrow, tonight, whenever you got time, just tell your parents, give me a quick bill and just have a quick read through it, read it together. It's a really good exercise. And I mean, eventually you'll have to do that anyways, because you'll have your own property and you'll need to learn to read the whole bill. An electricity company published the price of electricity available to consumers. Usually it does work like this. So it depends on the period of day that you're using it. If you're using on the on-peak hours, so when it's the busiest time, i.e. weekdays from 2 p.m. to 8 p.m. because you've come after school, your parents are coming from work, etc. It is the highest amount of usage, so therefore it's the highest rate that you get charged. From 7 a.m. to 2 p.m. and from 8 p.m. to 10 p.m. So the extra hours of the day, and then the morning hours, usually when you're waking up. They're called the shoulder hours, and they're charged usually half, or in this case it's just under half. And weekends from 7 a.m. to 10 p.m. Usually most people are at home, so therefore that's part of the everyday hours. Off-peak would be usually when everybody else is sleeping. So 10 p.m. to 7 a.m. From 10 p.m. to 7 a.m. you get charged at a very low rate. So let's just say if you were cost conscious, what you would do is run your electricity, the highest electricity output, so like your washing machine or your hot water systems, at off-peak hours, because you're getting charged a fraction of the price. Okay, that all makes sense?
Yeah.
There are things that obviously cannot be turned off, like your refrigerator and your freezer. Otherwise, everything else can actually be turned off. Okay, really easy. Complete the table for the use of these appliances at peak time. So refrigerator, the power is 400, the use is 6 hours. What's the energy used in kilowatt hours? It's not 400 times 6. Don't forget that gives you watt hours. So that gives you 2,400 watt hours. If you want a kilowatt hours, you're just going to divide by 1,000.
Yeah.
So 2.4. Cost, look, it's really easy. I'm not even going to be bothered doing that. You guys just times it by 53.911 cents. Okay, we'll do a few more. We'll do this one here. 4,000 times 0.75 divided by 1,000 is 3 kilowatt hours. Just confirm that, and I'll do the last one. Okay. Everybody's happy with those answers, or those numbers?
Yeah.
How much is saved? You're making me do it. All right, fine. Dishwasher. How much is saved? So 3.6 times 53. 3.6 times 53.911. That's 194.0796 cents for this. If you want it in terms of dollars, you just divide it by divide by 100. Sorry, that's about $1.94. So how much is saved if the dishwasher is used for 45 minutes in off-peak time rather than peak time? If the dishwasher was used for 45 minutes, how many hours is that in 45 minutes? Sorry? How many hours are in 45 minutes? It's not 0.45.
Isn't it just 60 divided by 45?
Other way around.
It's 0.7.
Isn't 45 just, 75%? So
Yeah.
3/4 or 0.75. But anyways, 45 over 60. That would be your watt. That becomes your hours. Then eventually you're going to divide by 1,000. True?
Mhm.
That gets you to your kilowatt hours. So let's quickly do that. 2,400 times divide by 100. Looks like it is 1.8.
Yeah.
And then off peak would have been, of course, 15.191. And then on peak would have been 1.8 times 53.911. And then obviously you know what we're going to do. We're just going to subtract the two answers. That's how much you save. So 1.8 times 69.
Yeah.
69 cents. Don't forget that. These are still in cents. So be careful. Cents. You would have saved 70 cents. Now, obviously, it doesn't sound like much, and it probably isn't much. But if you did it every single day, 70 cents times 365, you would have saved yourself about $254 a year. Now that sounds like a lot, doesn't it? Because only from a dishwasher. If you did that with your dishwasher, your dryer, and your, let's call it your washing machine, you could have saved about $700-800 a year, which becomes your car registration, which is for free. Okay? That's where math is used in the real world. Margot's television is turned on from 7 a.m. to 10 p.m. every day. Wow. All day. Great. Of the week. What is the total cost of the electricity over the 7-day period? Television, 200 times 4.5 divided by 1,000 is 0.9 kilowatt. Oh, what am I doing? Sorry, I times by 4.5. It's 200 times how many hours from 7 a.m. to 10 p.m.? 12, 13, 14, 15 hours. And then divide by 1,000. So that becomes 3 hours. And then she's doing it for every day. So times by 7 hours, 7 days. That's 21. And then what's the total cost from 7 a.m. to 10 p.m.? From 7 a.m. to 10 p.m.
The times by 22 point.
No, I stuffed it up. They didn't give me enough working out, so I didn't think I had to do that. All right. No, because if it's from 7 a.m. to 10 p.m., I have to take on, first I have to do it from 7 a.m. to 2 p.m. and 8 p.m. to 10 p.m. at this rate. And then,
Yeah.
and then from 2 p.m. to 8 p.m. at this rate.
Oh, yeah.
Yeah, so you got to break it up. Oh, well. Look, it's not all bad. I'm at 21. Oh, yeah. Let's go back for a second. This was 15 hours. Yep, for 3 kilowatt hours. I'll do it for this one, weekends, 7 a.m. to 10 p.m. So that's, I'll just times that by 2 days. That gives me 6 times 22.594. But there's no way I'm going to fit everything into here. Plus, the other one's going to be 3 kilowatt hours. No. All right. I need more space, so I'm going to stop that. Does everybody understand what I mean by I've got to break it up? Because it just doesn't work out.
Yeah.
Yeah.
Yeah. All that. And we will open up a new one. Okay. You'll get access to this. You see on our Skype page, this conversation right here. This was your recording that we just did today before I had to, before we finished off equations. And this is your recording from last week. Remember, they're only going to be available for 30 days. So if you don't actually press this little button here and save, it will disappear. And then when you're trying to go back and review everything, it won't be there. So I recommend saving these videos. But I'll send this document as well to you guys once we finish off. Paste. All right, that's better. All right, Margot's television is turned on from 7 a.m. to 10 p.m. every day of the week. All right, here we go. So let's do this. Firstly, we said weekends, 7 a.m. to 10 p.m. plus weekdays has to be from 7 to 2, which is how many hours? So 7 a.m. to 2, 8, 9, 10, 11, 12, 1, 2. So 7 hours plus 9, 10. So weekdays, 9 hours at 22. And then again, weekdays from 2 p.m. to 8 p.m. So that's 6 hours at 53. Yes, does that all make sense?
Yeah.
So 9 hours, because you've got to go from 7 a.m. to 2 p.m. and 8 p.m. to 10 p.m. That's 9 hours. And then the rest is from 2 p.m. to 8 p.m. at 53. And then we're going to do weekdays for times 5, of course, five weekdays. All right. So, what was it? It was television, which I think we had at, television was 200. The power is 200. Okay, so for weekends, the math is going to be like this, right? 200 watts times 15 hours divided by 1,000. Now you've got it in terms of kilowatt hours. And then that's per day. You're going to times that whole number by 2. Now you got it for 2 days. And then to find the cost, you're going to times it by 22.594. Weekdays. Weekdays are going to work like this. 200 times 9 hours divided by 1,000 times by 5 days times by 22.594 equals, and then that plus this one, which will be 200 times 6 hours divided by 1,000 times by 5 days times by 53.911. And that should give us our final answer, which I have to do slowly now. Just look at that, tell me what bit you don't get or what bit you want me to explain again.
I got 662.376.
Correct? Cents. Don't forget that's all in cents, right? So then you divide by 100. So watch it every day. At that rate, it's going to cost her about $6.62.
Yeah.
Per week. Again, which isn't too bad, given that she's watching so much. Okay. Does that make sense to everybody else as well?
Yeah.
All right.
Yep.
Okay. Yeah, I'll do one more. Actually, let's do one more. Let's do two more. We'll do both question 4 and 5. Why not? Because I think that's it, isn't it? Yep. Then you get a little test. All right, we'll do question 4 first. Four friends are house sharing. Oh, that's sweet. On average, each person uses 12 minutes of hot water each day. Their house has a 9 kilowatt hot water service. If electricity is charged at 31.25 cents per kilowatt hour when the hot water is being used, what is the cost of electricity for the hot water in 1 year? That's a typical exam question. So they all give it all in the one line. They're not going to really break it up for you. So you start from the top again. Everybody misses that number there. So 4 friends. So we're going to remember that there's 4 of them. On average, each person uses 12 minutes of hot water each day. So we know we can't use 12 minutes. It's going to be 12 over 60. We've got to have it in terms of hours. Their house has a 9 kilowatt, so 4 people times. They're using it at 9 kilowatts, which is nice. It's already at kilowatts. I don't have to change that to divide by 1,000, right? It's already in kilowatts. Times by the hours they use it at, which is 12 on 60. Do we all agree with that at least so far? 4 people using it for 12 minutes in terms of hours, and then 9 kilowatts. So now I've got kilowatt hours. They use it for 1 year, so that's per day. 4 people per day times 365 days times, easy, 31.25 cents. So just a whole lot of multiplying, isn't it? That's it. You're done. 4 times 9 times 12, 160 times 365 times 31.25.
82,125.
Yep, don't forget, we don't want it really in cents.
So put it into time divided by.
Good. Don't let the words get to you. Don't say this is confusing. See how simply I broke it up. I've made it really easy, so hopefully if you learn it at school, don't feel like it's any more complicated. You're just looking for kilowatts, there it is. You're looking for hours, there it is. There's 4 of them, there it is. Each day, so 365 days, and this is how much it costs. Simple. Question 5. Let's try it again. During winter, Lily uses a 2,400 watt. We don't like that because we want it in kilowatts, but we'll come back to that later. 2,400 watt fan heater for an average of 8 hours every day. Electricity costs dollars per kilowatt. What will be the cost if Lily used the heater for a total of 68 days? Okay, I feel like it's easy. Bianca, you want to try it?
Sure.
All right, go. First, we need kilowatts. So that would be 2.4. You can see it. Times hours. What are you going to say?
Times 8, and then
how many days per day?
68.
For 68 days. Now you've worked out how much energy you use, right?
Yeah.
For the whole 68 days, you're going to times that by
0.4526
dollars this time, not cents. And whatever answer it gives you is the actual answer we're looking for.
590.91456.
590.91.
Yeah.
Because we're dealing with money now, you've just got to round up to the second decimal place. Good job. Everybody's happy with that?
Mhm.
Right, now I guess up to you guys as a decision. Do you want to start another topic today for the last half an hour, or the topic I would have personally wanted to do would have been time, but I mean, or we could just do the topic test of this measuring energy, and then looks like next week I would very likely be doing, I think next week I'll literally finish off chapter 1 and chapter 2. Because chapter 1, most of it's easy, it's just a bit of revision. It's more the chapter 2 stuff that we've got to look into. So that would be next week. What do we want to do? So you want to start on time, or no, let's not get confused and too many topics in the one day. Let's just do the topic test. What are we thinking?
What do you reckon is the better option?
Sorry?
What do you reckon is the better option?
I think we do a little bit on this medication test and a little bit of this energy stuff. That's what I would do. I wouldn't really do time right now because that itself, like with time zones and everything, is confusing. So, done. Let's do that then.
Yeah.
Okay. All right, your turn. So let's, nice and simple one. Let's do question 7, please. Do that on your pen, paper. I'll give you about a minute and then I will go through it. Okay, let's do this one. So, what's our answers firstly?
I got 7.
Yeah, I got 7.
We agree with 7. Anybody
Yeah.
not agree with 7, I guess?
Oh, I got 7.
No, I got 7. Yeah.
No, done. Okay, this one, B. What would be your first line? I shouldn't see fractions. If you're going to do a really professional way, there should be no.
Cross
I got
multiply.
2x plus 3x equals 60.
I love that.
Yep.
That's it. That's exactly what I want to see straight away. So pretty much, did anybody not get that, or
No, I got that.
everybody's good with that? Okay, then that's it. Sounds good. X equals 12. Find R. Well, that's easy. Just plug in A and little r. That's nothing. This one, you're just going to times this side by 2 and then bring x's on one side, numbers on the other side. That seems easy. Patient is to receive 1.8 liters of fluid to be delivered at a constant rate by means of a drip over 10 hours. Each milliliter of fluid is equivalent to 15 drops. How many drops per milliliter? Okay. First read that and we'll do it together. But read it, maybe do what you think you would do. A milliliter of fluid is equivalent to 15 drops. How many drops per minute? All right. Anybody have any ideas? Each mil is 15 drops.
You convert to
Yeah.
milliliters. It's asking for
At least get
Yeah.
one mark, right? If it's 2 marks, try to get 1 mark. Times by 1,000, that becomes 1,800 mils. And you know, each mil is equivalent to 15 drops.
15.
Say it again.
Would you times by 15?
Correct. So I was going to say, how many drops will you have? If each mil is 15, you've got 1,800 mils. You're going to multiply by 15.
so 27,000.
So you got 27,000 drops that need to go into this body.
Yeah.
And it needs to happen in
10 hours.
10 hours. So now it's up to you. You want it per minute, right? You've got to make a
Yeah.
decision. Are you going to divide that into hours and then into minutes? Yeah, why not? Or do you want to convert 10 hours into minutes straight away? Doesn't really matter. I'm going to just divide it straight away into minutes. So 27,000 divided by how many minutes are there in 10 hours? 6,000, isn't it? 10 times 60. Oh no, 600 was right. Yeah.
45.
And
Yeah.
then 45 on the dot.
Yeah.
45 drops per.
I know. A minute, sorry.
Cara, Dahlia, that all makes sense?
Yeah.
Make T the subject, well that's easy. V, my U, you subtract the U, you divide by the A.
Yeah.
Find T, just sub them in. Simple stuff, simple stuff. All right, I am going to make you do 13. 13. I'm going to just warn you. Careful with the 3. When you multiply it, just be careful. That's my clue. Let's see if you guys make a mistake.
God, okay.
Okay, so Dahlia, when you multiply by 3, can you tell me your next line?
I haven't done this yet. Would we move the -5 over first, or we move the 3?
Yeah, that's smart. It's up to you. Are you going to plus 5 first? Did anybody else not plus the 5?
Yeah, I didn't.
Okay, so what was your answer then?
My answer overall was -6.
But what was your first line? So 2x plus
2x plus 3 minus 15
Yes.
equals 3 bracket x minus 2.
yeah, done. You would have done it right.
And
Dahlia,
then,
same thing for you. You would have got something like this: x minus 2 plus 5 is plus 3, and then you would have times it by 3. You're saying. So you should end up with the same answer, which is
X equals -6.
looks like
Yeah.
it. 3 take away 15 is -12. Minus 6 plus 12 is positive 6, but because you're going to bring it over, it's going to be -6 equals 6, which means x equals -6. 3 marks. Amazing. Anybody want me to go through that a little bit further in detail? No? Okay. These ones are easy. Find the adult dosage. So you're just going to find this, which means you'll have to times by 70 and then divide by the weight. Simple. Find Jack's reaction time. Okay, correct.
Right.
If he's It is driving at 42 kilometers per hour and has a reaction time distance of 22 meters before he applies the brake. Okay, no problems. Again, we're going to work out this in meters per second. So we just divide it by
3.6.
6. Yeah.
Yeah.
becomes 11.66, repeater.
Yeah.
Meters per second. And you're going for 22 meters, so you got to go 22 divided by distance over
One.
speed equals time.
1.89.
And what does it say? Does it say anything? It just says to 2 dp, so 1 point, yeah.
Okay.
Seconds. It's pretty slow, actually. You should have reacted a lot faster than 1.89 seconds. But, yes. What is BAC? That's easy. If A, find Y. Really?
Just substitute.
Yes, it's simple. Why would that be worth 3.5? Anyways, all right, let's move on. I'm happy with that. Okay, yeah, simple question. Question 1. How many square centimeters are in 2 square meters?
We're timing by 100 squared.
So
20,000.
yeah.
Yeah. Okay.
Number 2. Lucy measures the height of a bookshelf, 180, near a centimeter. What is the percentage error?
What percentage error? Okay. Yep. So
So 0.5 over 180 times 100.
That's
Mhm.
it.
So it is B.
B.
yeah.
Okay. Sig figs, significant figures, is just the first 2 numbers that you'll see. The first 2 numbers. So significant figures would be this. This would be first number. This would be the second number. Obviously, anytime you're rounding, you always look at the one after. What does the 8 do to the 1?
To a 2.
Yeah.
So technically, that's what you have to 2 sig figs. And then if you have to write it in scientific notation or standard form, it just means 3.2 times 10 to the power of.
Yeah. C.
Mole uses 3,000 watts, 45 minutes every day, used in 1 week. Go and work me out the kilowatt hours in 1 week. Yep, I've got my answer. Did anyone not know to do that?
Is it 15.75?
15.75.
Yeah.
Clara, Alyssa, are you guys alright with this?
Yeah.
Alright, sweet. Sweet. This one's easy. Okay, let's just do this on the same page. 3 sig figs. Let's plug this into our calculator. I got 9271.259. It wants it only in 3 sig figs, so 1, 2, 3. What does the 7 do to the 2? Makes it a 3, so my answer is not 903, because this was 90,000. So this still has to be 90,300. keep that in mind. And then again, it says standard form, so it's 9.03 times 10 to the power of 1, 2, 3, 4. Do the same thing for this one.
So 0.06568. Blah, blah.
366, 1, 2, 3. What does the 8 do to this one? Makes it a 7. Like those. And then your answer is 0.57 times 10.
Power of
One.
negative.
You're going back to, you're starting here, 1.
One of these ones.
Say it again.
One of these ones.
Yeah, I don't want to really do that. Sounds annoying. So we're just going to do number 8 instead. And then we'll come back to it. Let's do 8 first. See how we're going. Kylie and Laurie measure the height of 2 different shrubs in there. So let's measure what is the absolute area of Kylie. Okay, I'll leave that with you. I'll give you guys a few minutes just to work it out.
Um, 0.5 and 0 and what?
What's
Wait,
your
Becca,
first?
did you get 0.5?
0.5 centimeters is correct. And what is the percentage error?
3.
I was
0.5.
0.3.
Yeah. 0.5 over
0.3.
3.
3C.
It says 2 decimal places. So if you're saying 0.3, Christian, it can't be right.
3C.
0.3.
Yeah, careful. Look at this. Ready?
I
That
would have lost the mark.
1.
Yeah.
That's it. You did all the work in out. You did everything. Just because it says 2 DP, you just lost 1. It's not worth it. Be careful. 2. All right. Emily, yeah, this is easy. Blah 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 blah. Yeah. We could do this one, but I'd rather do this. All right, let's stop our recording now. I think we're good here.